So welcome back. In continuation with the previous class, today we will try to understand a problem based on your sum of IID random variables. Okay. So in the previous video we have seen what is the meaning of IID and how it is affecting our PDF mean and variance as well as characteristic function. So that all has been covered in the previous class. Today we will go ahead and try to understand the next very important thing, that is how to find your PDF mean, variance and characteristic function of a IID random variable. Okay. So let us first go through this exercise. Okay. That is the example. This is a solved example in your textbook. So let me read the problem. Let W be the sum of n independent and identically distributed exponential random variables. Find the PDF mean, variance and characteristic function of nth order Erlang random variable. Okay. So here what I have given here, friends, is that let W be the sum of n IID random variables, and these are what type of random variables? These are exponential random variables. So I have a note here, these are n IID exponential random variables. That is the difference. We need to find our PDF mean, variance and characteristic function, okay, of nth order Erlang random variable. So if you just recall all the previous classes, we have already seen your Erlang random variable. Okay, but it was not a nth order Erlang random variable, but we have studied your Erlang random variable. And I have also told in the previous videos that you might get a question in your examination saying that find the PDF of Erlang random variable. Okay, so therefore if this is the question, we know that our exponential random variable is given by fx of x, which is equal to lambda into e raised to minus lambda x, and where it is visible in the range when x is greater than or equal to 0. For all other values it is 0. Okay. And now remember, friends, its mu, variance and characteristic function will not be given. We need to remember these things, and these are of what now? These are of IID exponential random variables. So whose mean is what? 1 by lambda. Its variance is what? 1 by lambda square. And its characteristic function is given by lambda into lambda minus j omega raised to minus 1. So this, friends, this whatever we are seeing right now, this has been covered in the previous problem. Okay, we have solved a problem on this. Okay. Now moving ahead, let W be the sum of your independent observations. Then we write it as W is equal to x1 plus x2. So using convolutional integral for the PDF of W, we will be solving the problem. So whatever I am trying to tell in this problem, I have just reproduced this from the previous problem which I have covered. Okay. So if you can observe here, this is my formulae for the PDF. So it is minus infinity to plus infinity, fx of x, fy of w minus x into dx. We have also proved this formulae. Yeah, we also proved this formulae. Next, what would be my limits? So we have changed our limits to 0 to w, and I have explained you why it is 0 to w using the diagram. So next thing is, we need to introduce our fx of x. It has been given here, it is lambda into e raised to minus lambda x. So substitute that thing. Next, we need to substitute our fy of w minus x. Our fy is what now? It is f of x2. Here instead of fx, you can write fx1. Here instead of y, we need to write our x2. Okay. So we already know that it is nothing but, you have this formula. Just we need to what now? Shift and replace. So it is nothing but just replace this w minus x in the place of x. We have a x here. So instead of x, we will be writing here what now? W minus x. Now after simplification, the answer you will be getting is c into lambda square w into e raised to minus lambda x, where it is in the range of w greater than or equal to 0. So this is the PDF for an Erlang random variable of order 2. The same thing in detail I have explained in the past class. So please go through that class. If you have any doubts in this, the same thing I have explained. Okay, I have just reproduced that thing here for the continuation. Why I have reproduced here is because if they ask a question, if they ask a problem of such type, you need to write what all things that the students should understand. So for that reason, I have reproduced the whole thing here. It is the same thing. Now, so this is done. Next thing is what now? We know the PDF Erlang random variable of order 2, but what is the question they have asked? We need to find for nth IID. We need to find it for n IID random variable. So therefore, next we will try to find it for W3. You can see here W3. Okay. So it is nothing but minus infinity to plus infinity W2 of u fx into w minus u du. Okay. So here I have taken u, friends. You can take here x only. If you take here x, integrate with respect to x. That is the change. Next. So this is nothing but 0 to w. Just use the PDFs which has been given already. See here, it has been already given here. So use the same PDF. It is nothing but lambda square into u e raised to minus lambda u. Just I have replaced x with u. That's all. Similarly, here it is w minus u. So therefore, wherever you have u here, just replace it with what now? W minus u. Fine. So what is the happening here now? We need to simplify it. This lambda square and this lambda will be multiplying. You will be getting here lambda cube. E raised to minus lambda w and e raised to minus of minus, this will become plus lambda u. That is separated. Okay. So that means I will just, if it's confusing, I will add one more step here. Please concentrate. Okay. So we need to simplify this thing now. How this could be written? This could be written as e raised to minus lambda w multiplied by e raised to lambda u. Okay. That means this minus and this minus will be converted into plus. So that's why you are getting here e raised to lambda u. Okay. So that means I'll just erase this out. So these are the two terms. Apart from that, you have here one more e raised to minus lambda u. So this e raised to minus lambda u and this e raised to plus lambda u, both would get cancelled. What is remaining, friends? Only this e raised to minus lambda w. So that has been written here. So lambda square into lambda is what now? Lambda cube. E raised to minus lambda we have taken from here after simplification of this exponential term. Okay. And what is remaining inside then? The only term which is remaining is this u. This u is remaining. That's what we have written here. And it has to be integrated with respect to 0 to w. Okay, friends. So that is what has been done here. Give me a second. Okay. So once you integrate it, what you will be getting? The integration of u. The integration of u is nothing but, one second. The integration of u is nothing but u square by 2. Fine. So this is equal to what now? This is u square by 2. You need to put the limits what here? 0 to w. So the limits you will be using is 0 to w. Thereby, how it would be converted? This u is converted into w. So this becomes w square. Okay. That means this becomes your w square. So the same thing has been substituted here. So you can see here w square by 2. Fine. Lambda cube is as it is. Lambda cube is as it is. E raised to minus lambda w is also as it is. So the final answer you will be getting is e raised to minus lambda w, fine, multiplied by lambda cube into the w square divided by 2. And where it is? When w is greater than 0. For all other values it is 0. So this process has to be continued for n variables. So when we continue it for n variables, please observe here, friends. This is fw cube of w, right? What you have got here? Lambda cube. Observe the powers. Here you have a 3, here also you have a 3. That means how this could be written here? It is lambda of n. When you want it for nth variable, it becomes lambda of n. Fine, that is clear. Next, if you observe the next step, here you have a 3. We are finding the PDF of w3, but what we have here? W square. That means 1 power less. So therefore, what we are written here? W raised to n minus 1. So going forward, the next thing is, here you have a 3, right? But what you have here? 2. Okay. And in the previous time, here you have a 2, but what you have here, it is divided by 1. It is divided by 1. So this is a factorial. That means when you have 3, what we have written here is 2 factorial. What is 2 factorial? 2 into 1. When you have here 4, you can try with finding f of w4. What we will be getting here is, this is nothing but lambda raised to 4. This is omega cube, 1 power less, and this is what now? 4 factorial, which is 4 into 3 into 2 into 1. Okay, since we have here 3, it means what now? Here it is lambda raised to n, which is 3, and this is 1 power less, that is 3 minus 1, 2, and this is 2 factorial, which is just we have written 2. Why? Because 2 factorial is 2 into 1, which is 2. So this is nothing but your n minus 1 factorial. Okay, and e raised to minus lambda w would remain the same. So I hope this nth term is clear. Okay, so I'll just give a glance of once again. Since we have f w of 3, that is for the omega 3 is the convolution for third variable. Similarly, for nth variable, it would be lambda raised to n, 1 power less. So therefore, w raised to n minus 1. Here it is 2 for the third variable. There it will be what now? N minus 1 factorial. Okay, so this is the Erlang random variable of order n. That was asked in your question, and we have deduced it. This could be also asked as a derivation. Okay. Next, similarly for nth variable mean, just 1 by lambda is there, just multiply it by n. You can see here will be multiplied by with n. For variance, you have 1 by lambda square, just multiply it with n, thereby you have n by lambda square. Similarly, for your characteristic function, we already know your characteristic function, it is here, see here. This will not be given now, friends, you need to remember it. Okay. So it is just multiply it with n. You will be multiplying this with the power of n. That is lambda raised to n, lambda minus j omega raised to minus n. So I hope the problem is clear. They might ask this problem as a derivation, like say for example, they might ask you to find derive the PDF mean, variance and characteristic function of nth order Erlang random variable. Such type of question they may ask, or they might ask it in the form of a problem as well. Anything could be done, any one of them. Okay, so please do it carefully, and if you have any doubts, you can come back to me. Thank you.